Okay, what about pre-chemistry? Haha, 3. Okay, so now let's talk about little more things about these atoms and periodic table, things like that. Let's look at this combining two atoms. Okay, actually bonding. Okay, what kind of bonding? Okay, wait a minute. So we talked about this one already. This one is a -2. That's why we give this one 2. This one is a +3. Okay, that's why this one 3. So aluminum oxide. Okay, it's a binary chemical, right? Also, this kind of bonding we call ionic bonding. So because ionic bonding, because depends on how many ions, okay, how many positive ions, how many negative ions. Okay, that's why. Yeah, other than this one, so we have so many other bondings like a carbonic bonding, hydrogen bonding, okay, peptide bonding, things like that. Okay, but we're going to talk about those things later, okay? Okay, I drew one, that's right, atom right here. You know what kind of atom? I drew this one, okay, for Na, which is sodium. Okay, obviously sodium, you look at this sodium right here, okay? Sodium is 11, okay? That means number 11, that means, 11 protons and 11 electrons. Electron, usually we write like negative right there. That's outside the shell. Okay. They have so many shells like K shell, L shell, M shell. Okay, things like that. So, hey, let's talk about that one later. Anyway, but now inside, that's nucleus. Oh, nucleus. Man, dangerous, right? So nucleus right here. Okay, nucleus, usually we separated this one by maybe about half and half, okay? So also we have a positive side, so we call proton, okay? So electron is outside, negative charge, okay? Inside, in nucleus, we have proton, okay? Positive charge. What about, positive, negative together? So we call neutron, okay? That's neutral, that's why neutron, okay? So now, proton and neutron. What about the weight-wise? See, okay, this weight, okay, proton and neutron, exactly same weight. Okay, that's why one proton, okay, let's say one neutron and two neutron, and together make 3. So weight is 3. So now, we don't count this electron. Electron is so light, that's why, okay, maybe 1 divided by 2,000. In other words, 2,000th that's right, 2,000th of 1 proton weight. That's 1 electron. That's why we just ignore it, okay? So now, that means we call GMW, which is gram molecular weight, okay? Gram molecular weight, we just add how many protons, how many neutrons, that's it. Okay, let's say, what about sodium right here? Okay, Na, which is 11, that's why 11 protons and 11 electrons. Okay, now, how many, for the sodium, how many neutrons? That's 12 neutrons, just happening. Okay, so together, we call gram molecular weight equals 23. Oh man, 23 right there. That's why we call this one 23 is weight for that. Okay. Oh, what about normal hydrogen? Oh, weight is 1. That's why no neutron, but isotopes. We have isotopes. We're going to talk about that one later. Okay. Anyway, hey, make it simple. What about helium? Oh, usually this weight is about twice of this number, okay? This number is 2, this is about 4. Okay, what about lithium? Actually, double is 6, but one more, which is 7. Just like sodium. Okay, what about potassium? Oh, double is 38, but actually one more, which is 39. Easy to remember. Okay, what about calcium. Calcium is exactly double. Oh, that's it, double. So remember, left-hand side, okay, so lithium, sodium, potassium is a double and plus 1. Oh, man. Let's talk about very, very important one first, okay? So carbon, oh, that's double, so 12, see? So molecular weight. So now what about oxygen? Very important. Oh, that's right. This one is 16. Oh, remember that. Okay, what about nitrogen? Oh, exactly, double. So these three right here, double, double, double. What about beryllium and boron? Oh, double plus 1, which is double is 8 plus 1, which is 9. What about this one? Double plus 1. Okay, so 10 plus 1, 11. Whew, very interesting. What about neon? Oh, double, that's it. Okay, 20. What about argon? You know what? Happening. This one is a 40. You better remember this one, chlorine. Okay, 35.5, 35 and a half. Okay, so you're gonna use this one a lot. Oh, what about this one? Oh, this one, double. What about this? Double plus 1, which is 19. Oh. What about silicon? That's right, double. Okay, which is 28. Okay, what about, oh, phosphorus? Double plus 1, which is 31. Okay, what about magnesium? Double, 24. What about this one? Oh, double plus 1, which is 26 plus 1, 27. Okay, you gotta remember somehow all this one. If you remember all this one, oh man, I guarantee it. Okay, you're gonna get A on chemistry class. Okay, let's talk about fluorine right here. Fluorine. Fluorine, number 9. That means 9 protons and 9 electrons, right? What about neutron? Oh, that means, okay, look at this weight. Weight is 19. That's why 19 minus 9, which is 10. Oh, 10 neutrons. Fantastic. What about this potassium? Oh, potassium is number 19. Okay, so 19 protons and 19 electrons. Okay, then what? Oh, 39 is gram molecular weight. So 39 minus 19, which is 20. Oh, 20 neutrons. Oh, neutron looks like this. Okay. Oh, let's talk about one acid now. How about, ooh, see? SO4. Oh, man. Almost everybody knows this one. Okay, first of all, so we have to know, that's right, what is the valence? Okay, valence for this one? That's right, let's check. Okay, S, oh, S, where is S? Oh, right here, oh, that means, oh, negative 2, right? Oh, negative 2, so right there, negative 2. Okay, what about oxygen? Oxygen, oh, look at this oxygen. So negative also, right? Okay, negative 2. But, okay, look at this one. Always the chemical, left-hand side is positive and right-hand side is the negative. Then we treat this one like a positive, okay? Okay, let's count again for S, which is sulfur. Wait a minute. That means from the left-hand side, that's positive, right? Positive 1, positive 2, positive 3, 4, 5, and 6. Oh, then we can call this one also positive 6. Okay, wait a minute. Okay, negative. Okay, oxygen is negative 2. Negative 2 times 4 is a negative what? That's right, negative 8. That's why total valence for SO4 is negative 2. See, because of positive 6 and negative 8. So negative 2, right? Okay, forget about all this one now. Okay, total valence for SO4 is negative 2, right? Okay, now, the problem is how many hydrogen we need. Ah, man, hydrogen. told you hydrogen is number 1, right? It's one column. That's why positive 1. Now, this one is only one positive. See? That's it. So now, what about the right-hand side? Negative 2. That means, another word, 2 girls and 1 boy? No. That's why you need 2 boys. Then we can match. Fantastic. Okay, that's why H2SO4. Oh man, that's it. This is what? Sulfuric acid. Oh man, sulfuric acid, which is, that's right, car battery, right? Battery in the car. Okay, so they use sulfuric acid. Very dangerous. If you touch that one, not good news. Now, let's find out GMW, which is gram molecular weight for the sulfuric acid. Okay, 1 molecule of sulfuric acid. First one, hydrogen. Each hydrogen weight is 1 right here. Okay, that's why. That's right. Okay, 1 times 2. See, this one is 1 times 2, which is 2 right here. See, totally on this one is a 2. Okay, now what about sulfur? Okay, sulfur is 32. So, okay, 32. So, 32, we just write this one down right here, 32. What about oxygen? Each one, 16. See? So, 16 times 4, which is 64. Wait a minute. All we have to do, we add all this one, right? Okay, 2 right here. Okay, and 32 and 64 all together 98 grams. That's right. Each molecule, the weight is 98 grams. Okay, so that's why we call this one gram molecular weight. Okay, you know what? We can enjoy more and more. Okay, so far we were talking about just inorganic chemistry. Organic chemistry, we're talking about carbohydrate, protein, fat, things like, oh man, you will love them, okay?